Okay, class, today we're going to be going over functions. We've already talked about it, but a lot of you struggled with it on the last exam, so I'm going to make a number of problems here directly related to it. So here we will be going over functions. Alright, in explaining this, I'm going to use an analogy. So, what is a function? Well, in real life, a function is just an operation you perform. You can think of a function almost as being a job. So, a function is a job. And we're going to talk about the first job I ever had. I worked as a busboy. So, as a busboy, what does your job entail? Well, a busboy must do a number of things. They must first, maybe they double as a host. You have to seat the client, patron, whatever you want to call it. Next, the busboy must fill water glasses. At this point, the waiter takes over. The busboy comes back. He cleans the table. And then he sets the table. So, the busboy's job, his function, includes all of these different sets of operations or things that it must be performed. Well, in the same case, a function can be thought of mathematically as some job being performed by some function. So, in math, your function is, like f of x equals something. So, functions are defined as f of x. And they can tell you any number of things, just like you can have any number of jobs telling you any number of things. So maybe your first function that we're going to talk about, we'll say f of x equals 3x squared plus 2. So what does this function tell you to do? Well, first, because of order operations, you must square x. You must then multiply by 3. And you must then add 2. So this particular function tells you to, whatever's in here, square it, multiply it by 3, and then add 2. So pretty straightforward example. Let's say we wanted to find out what the f of 3 was. So f of 3. So f of 3 would first tell you to square 3, then multiply by 3, and then add 2. So writing that out, f of 3 would equal 3 times 3 squared plus 2. Order operations, square first, 9 multiplied by 3, 27, plus 2 gives us 29. Alright, so this was a pretty straightforward example. Maybe we're going to have one that's a little bit more complicated though. So I'm going to rewrite f of x down here. So f of x equals 3x squared plus 2. But now let's say instead of f of a number we had f of some variable, f of m. Well, remember, the function is just telling you what to do to whatever's in here. So f is squaring, multiplying by 3, and adding 2. So f of m is, again, just going to be squaring, multiplying by 3, and adding 2. Nothing really changes except the x has replaced the m, just like the 3 replaced the x. But let's try something just a little bit more complicated than that. Let's say instead of that, we had f of m plus 4. Well, what's happened here is that m plus 4 has taken the place of x. So whereas before, f of x told us to square x, multiply by 3, and then add 2, f is now telling us to square m plus 4, multiply that by 3, and then add that to 2 if we wanted to fully draw this out. Remember that m plus 4 squared is not m squared plus 16, but rather it's m plus 4 plus m plus 4. And then, of course, we add 2 at the end. We would have to FOIL this. So we would get 3. That would give us our m squared. Come over here. Plus 4m plus 4m plus 16 plus 2. We then must distribute the 3. Whoops. 4 plus 4m is 8m. So the 3 being distributed into that is going to give us 24m. 3 plus 16 is 48. I'm going to add 2 to that, gives us plus 50. So fully extended out, the f of m plus 4 gives us this. Alright, let's think of other things that we can do. Well, maybe instead of changing what's inside of the parentheses, we're going to change what's outside of the parentheses. So maybe we want to figure out what, instead of like f of m plus something, maybe we want to figure out what 2 times f of m is. Well, remember, f of m is just 3m squared plus 2. And 2 times f of m would be twice this value. So it would be 2 times 3m squared plus 2, which would lead us to 6m squared plus 4. Should be pretty clear exactly what I'm doing here, but let's try doing multiple things. Well, actually, one more quick example before I go on to that. Let's say I wanted to find f of y minus 4. Well, f of y is just 3y squared plus 2. So let me mark this in color here, give you a nice visual. So my f of y is just 3y squared plus 2. But then I have to subtract 4 from this function. So I'm going to subtract 4 at the end. I'm going to do minus 4 right here. And we can see, that added little piece isn't changed because it's not a part of the function. But when we combine and simplify these terms, we're going to get 3y squared minus 2. So now we've pretty much seen everything that we can do. Most of you in pre-calc should be familiar with some of this stuff with transformation principles. But I'm going to do a couple of combination problems. So I'm going to write these out. Before I do them, I want you to pause the video and try them. So let's say we wanted to find 3. Oh, well, let me first define a function here. Let's make the function a little bit different. Let's say f of x is equal to 5x squared minus 4. Alright, so that's our f of x. And then what I want you to do is I want you to find the following functions. I want you to find 3 times f of 2z minus 8. And I want you to find negative 4 times the f of y minus 3 plus 2. Please pause the video and try this before continuing. Alright, I'm going to go ahead and do these. Find 3 times f of 2z minus 8. Alright, well the 3 and the negative 8 don't change. So I'm going to have a 3 here. And like it's being multiplied here, it's going to be multiplied by the f of 2z. Well, f of x is 5x squared minus 4. So f of 2z, I'm just, again, replacing x with 2z. It's taking the place of x here. You can see that. So it should take the place of x here as well. And again, anytime I substitute in anything for anything else, I put it in parentheses. Alright, so this is what I end up with here. Well, I need to simplify. So remember, this is like 2 to the first, z to the first. So going inside out, the innermost parentheses, this would become 3 times 5 times, I'm going to open up these parentheses by distributing the 2, so it becomes 2 squared z squared minus 4 minus 8. Well, in order to get rid of these parentheses, I have to distribute. Remember, distributing only happens when you have plus or minus signs. So this 5 times 4 is 20, times 3 is 60. So I'm going to get 30 z squared. My 3 got distributed to here, and then it must get distributed to the negative 4. So it's going to give me minus 12 minus 8, which is going to lead me to 30z squared minus 8. Go ahead and over here and do the next problem. Here we have negative 4f parentheses y minus 3 plus 2. So again, the negative 4 doesn't change. My f is now 5 times y minus 3 squared. Again, y minus e has replaced x, so it replaces x here. It sounds like I'm a broken record. It should. That's good. It means you're getting it. So first thing I need to do is get rid of this square on the inside. Because y minus 3 squared is y minus 3 times y minus 3, I would have to FOIL it out. I'm going to take a shortcut here. Y squared minus 6y plus 9. That's the foiling of this. It's going to be plus 2. There should not be a parentheses here. There should be no parenthesis there. That is my mistake. Alright, so it should be here instead. Oh, I messed up. Alright, can everyone see where I made the mistake in this problem? I forgot about the minus 4 there, so let me back this up. Back it up, back it up, back it up to right here. So my f of y minus 3 should have this minus 4 at the end, because 5x squared minus 4 gives me that, plus 2. So I'm going to do this. 5 times getting rid of the square gives me y squared minus 6y plus 9 minus 4 plus 2. I'm going to distribute this 5 to get rid of these parentheses. So I'm going to get negative 4 times 5y squared minus 6y plus 9 minus 4 plus 2. Combining the like terms inside, distributing the negative 4. Scroll down here. I get plus 9 minus 4 is 5. So negative 4 times 5 is negative 20y squared plus 24y minus 36. Distribute the negative 4 plus 16. And then plus 2. Notice this plus 2 is outside of the parentheses because it's not part of the function. So this ends up giving me negative 20y squared plus 24y minus 20 plus 2. And this, I could actually just combine this into minus 18. So my final answer would be negative 20y squared plus 24y minus 18. And that's the answer to the problem.